Now there is also a problem with numbers in JavaScript, and especially for the floating numbers. So let me write console log, and here, for example, we have 0.3.3 and plus 2.8. So let's see what is the result of these two added up together. So I'm going to refresh the page and after saving the code, and as you can see, the result is just a bit different than what we've expected. So it has a lot of digits after 3, and the result must be something about 3.1, but here it's 3.0999, and this is just a bit different than what we had expected. And why need so many digits like this, and why not so accurate? So this is probably one of the things in JavaScript that might irritate you, but the fix for that is so simple. To fix this, we can multiply the two numbers by 10. So let us multiply these two by factor of 10 and then divide all of these. And actually, I think it's better to multiply each of them by 10 and then divide them by 10 afterwards. And you might say, what is the difference? What's the difference? The difference is that 2.8 will no more be a floating number, so 28 will be added to 3, and this will be an accurate number, and the result will be 31. And then by dividing 31 by 10, we will have 3.1 as the result, and we will have no problem. We won't again anymore have that inaccurate number. So as you can see, it's 3.1, and we don't have that problem anymore. So this is one of the tips and important tips for adding up the floating numbers in JavaScript, and this fix will solve your problem if you have any problem at all. Now in the following, we're going to talk about the different methods and functions that we can use for numbers. So imagine that you want to write this format of scientific number, and you have a simple number, so you want to write it in that method. So for example, you have so let me define something like D, and so the number is 100,345, and you want to convert it into an exponential kind of format of showing. So here I can write D dot to exponential. So let's see what happens here for D dot to exponential. And as you can see, it shows the number in an exponential way. So it is 1 point and then a number, and then it is multiplied by 10 to the power of 5. So, but the actual number is 100,345. So this is the scientific way of showing the number. There are so many methods for numbers, for example, converting it to string or convert a string into number. We've talked about how to convert a number into string, but what about converting a string into number? So, for example, we have a number in format of string. So let E equal to, and then we have double quotes for the string, and then a number like 10.89. So we want to convert this to a a float number. So I can write console.log, and then inside of this I can write e dot parse float, or actually I should write parse float and then write the number. So e, by the way, you can write number.parsefloat or parsefloat. So save the code and see what happens here. 10.89. So how do we know that it's a number? I can write type of before parsefloat e, type of this, and also type of e itself, type of e. So let's save the code and get into Google Chrome. So the first one is a string, the second one is a number, and as you see, it's a flowing number, as you saw actually. So that's it for converting it into floats. But what if you want to have a string? You want to have an integer number. So you can use e dot parse int. Actually, we don't have e dot, we have parse int, and then we have e inside of the parentheses. So let's save the code, refresh the page, and we have 10. So what was the number? It was 10.89. So it has rounded the number downwards to 10. It could have done it upwards to 11. There are methods that you can do it upwards, but here it has rounded the number downwards to 10. So we have converted this a string into a number and an integer number. There's also another function for converting the number into a number, and without considering whether we want it to be an integer or a float, and that is using number. So console.log, and then we can write number, and then we write our variable, which is most of the time a string, because there's no reason for converting a number into number because it is already a number. So let's save this and refresh the page, look at the number. So it's 10.89, the number that used to exist here in the format of a number. Okay, and also there are times that we want a fixed number of decimals after dot. So we use toFixed. So let me define another variable, let f, and then we have, for example, a number like 10.89765934356121. Okay, doesn't really matter what numbers are inside after decimal, but then we want to console.log, and then here the number is f, and we want to have a fixed number. So here toFixed, we use the toFixed, and then we use the number of fixed decimals that we want. So we want, for example, we want 4 of the decimals, 4 digits after the dot. So we can write 4 here, and we can save the code, refresh the page, and as you can see, we have 4 decimals after the dots, 4 digits. We also have something the same as a fixed, but that will be applied for a number of digits rather than the number of decimals after the dots. It will consider all of the digits. So let's write console.log, and then in there, what's going on wrong? Okay, and here f to And then we have toPrecision as well. It is nearly the same as fixed, but this is not for the number of decimals. This is for the precision. So let us enter 4 here. Let's see, probably it works just the same as toFixed, but I don't think that's true. So there is an explanation here as well, number of significant digits. So so it's about the digits, not the decimals. Let's save the code, refresh the page. As you can see, we have 4 digits. So we have 2 decimals, but 4 digits. So the number 4 refers to the number of digits that we want to have, and we do not consider whether we have how many numbers we want to have after the decimal. So if it was a 4-digit number, for example 1090, then we wouldn't have any number after the decimals, so no digits for the decimals. Okay, so there's a difference between toFixed and toPrecision for the numbers. Also consider that, for example, with the parseInt, consider that we have a kind of a string that has an actual string in it. So we have letters instead of the numbers, or at first we have a letter and then we have a number. So let's see what happens in there. So let me define another variable. So A, B, C, D, E, F, G, and so let G be equal to, so for example, I can write 10 days, 10 days. So I want to console log and then we have G dot parseInt, and then we have G inside of it. So we want to convert this into an integer, and the result will be 10. But let us try this one. The answer is simply 10. As you can see, it's 10. But what if we have days, day number 10, day number 10. Save the code, refresh the page. As you can see, it says it's not a number because it considers the first one, and the first one is not a number. But what if we write this without any spaces between them? Save the code, refresh the page. Still, it's not a number because it looks at the very first character. It checks whether it's a number or not. So this is not a number. But what if we write space 10? So we have no character, we have a space, and then we have 10. Save the code and refresh. As you can see, we have 10, so it doesn't say that it's not a number. So if the character is a letter, it will consider it as not a number. So if I write A10 and then I refresh the page, still it says not a number. Okay, so that's how parseInt works, and you need to be very careful about that. Sometimes you will get the result that you want, and in other times you won't. The condition is that the condition works is a condition that the first character it finds here is a number. So what if we write 10A10? What will this be? Save the code and retry. As you can see, it says 10. So it looks inside of the string, and whenever it gets to a character which is letter, then it will not consider it as a number from that position of the string up to the end. So because we have 10 before the character which is letter A, we have 10 as a number inside of that string. But if we have the first character that it finds as a letter and then no number, it says it's not a number. So that's how parseInt, also parsefloat works. So I'm not going to try this for parsefloat because that is exactly the same way. We also have properties in numbers. So for example, I can say console log, and then inside of it write g dot, and I can write max value. So we don't seem to have it with capital letter, so it's a max value with capital letters, and also on the line. So let me check this on the Google Chrome. So it says undefined. So probably this one is not defined in the layers versions. Okay, and the reason is this is not a number. So first of all, it needs to be converted into a number, and then and also I think I should write something else. Number dot. Probably, okay, that's how it works. So we need to write number at first, not another number, and this one shows you the greatest number that you can use in JavaScript. Also, we have maximum saved integer, which is the maximum greatest number that you can use inside of the greatest number that you can use inside of the JavaScript. So let me save this, and here try. As you can see, it has this capacity of the greatness of the number. So it has about 308 zeros after 1. So it's a very, very big number actually, and that is how much we can use the greatness for the greatness of a number. But let us also check the max save integer. Save this and refresh the page. So it's a much smaller number. So that one wasn't a very safe one, although it had 308 digits, but this one has a lot less number of digits. It's about 7, 9, 11, 13 and 16 digits. So it only has 16 digits, so the safe maximum value of the digits for an integer in JavaScript is 16 digits. So keep that in mind. This is not a very useful one. This was just a property that you could check for JavaScript capacity of the numbers, but that is not a very useful one. But all of these other functions are most of the time useful, especially some of them which are for the conversion of the types. And so that's it for the numbers.